All right, welcome. Thank you very much for being here. My name is Brett Garino. I am going to be presenting this with Stephen Baca, who is to my left. We're going to be doing vSphere performance troubleshooting and root cause analysis. Now, first things first, please be cognizant of the amount of time that we have to go over CPU, RAM, network, and disk. It ain't much, all right? So we've chosen to go over a few key metrics relative to each one that can help you identify performance issues. So if you have additional questions, I will be happy to spend more time with you as needed after the session, or you can find me on Twitter, email me, whatever you need to do. Steven's available as well. If you guys need anything at all, feel free to reach out to us. Okay? If we don't happen to cover a topic that was part of your expectations coming into this, once again, we're very limited on time, so that being the case, feel free to reach out to us. We'll be happy to cover whatever that topic is with you in as much depth as you are willing to go. All right? So that being said, let's get started. First things first, we have a disclaimer, which I just gave a disclaimer of my own. This one's more about not reproducing material and things like that. Agenda here. We're going to look at ESXtop. This is the resource or tool that we will use and zero in on throughout this presentation for our Core 4 resource analysis. When we talk about analyzing CPU, RAM, network, and disk resources, ESXtop is critical to your success in determining when you have performance problems on your ESXi host as a result of virtual machine consumption. So we'll be looking at ESXtop first. Then, as promised, 4 resources. Okay? Compute resources first, then your I/O resources will follow. I'm going to cover compute with CPU and RAM. Steve will cover I/O with network and disk. So the ESXtop overview. When we look at ESXtop, this is a tool that you can run from ESXi shell local to the ESXi host. It may also be run by running our ESXtop, which is the remote version of it, through the vCLI or vSphere CLI. However you choose to run it, keep in mind this is a command that is limited in scope to a single ESXi host. That's okay though. As soon as you can narrow a problem down in scope to the single host, this is the tool you want to be using. Another beautiful thing about this tool is the fact that it is available in every single one of your customer environments. So that's a wonderful reason for you to master it. When I worked as a consultant more frequently than I do now, this is something that I had to know because I could always count on it being there for me in any single customer environment. Okay? It's based off of the Linux top command. So those of you who are already familiar with that, you've probably got some familiarity with this and how it actually looks. The key performance indicators, KPIs. For those of you who have worked with VROPS before, you've probably heard the term KPI. For those of you who haven't, these are the key metrics relative to each Core 4 resource that we want to focus on. So when I talk about CPU and RAM, I'll tell you things that when you go into ESXtop are going to be immediate indicators of resource constraint or concerns for you in your environment. Okay? Now, when we look at ESXtop and we want to run the command, you might want to hold your pictures because we're going to highlight these. Okay? There's going to be more on this. Here, I'll just get them all highlighted. There you go. Now take your pictures. You're quite welcome. All right, that way you don't have to take a picture for every click. Oh wait, something got red. All right, so when we're doing this, in ESXtop, I always tell people you just need to remember 2 things to be able to use ESXtop. The command itself, which it's in the name, that's pretty easy, and then the letter H. If you strike the H key, this is what comes up, and it tells you your other options. The default screen is always going to be CPU, which we'll be looking at in just a bit. And you can strike any of the other keys to go to a different screen. Now you'll notice that disk is unique. CPU, memory, and network only have 1 screen. Disk, however, has 3 screens. Stephen will talk about why, okay? And how you analyze the disk metrics from each of those screens. You also have a virtual machine view, which is used to analyze the virtual machine statistics for disk, okay? So that's why when you look at the lowercase v up there, and the keys you strike are case sensitive within this. When you look at lowercase v up there, we're actually identifying virtual machine disk metrics, all right? Uppercase V is going to let you sort the view so that it doesn't show you all of the daemons or services running on your ESXi host, and it will limit the view to only your virtual machines. This is huge because when you go into ESXtop, typically you're going to see 500-600 services listed. You can't see all of them. And you probably won't see your virtual machines either, okay? So what you need to do is hit Shift-V when you're on the CPU screen, and it will limit it to only the VMs that are currently powered on and running on that host. And this is good for the CPU screen and the memory screen primarily. Okay? On the network and disk screens, not so much. But on those two screens, CPU and memory, as soon as I hit those screens, I usually do a Shift V, drop it to only my VMs. Because what I want to see is my host-consumer relationship. Okay? Provider-consumer relationship. ESXi host being my provider of resources, the virtual machines being my consumers of resources. If the provider has adequate resources, my virtual machines are properly configured, I shouldn't have problems. If I do have problems, I can identify that in ESXtop. That's what we'll be talking about as we continue. So first up, CPU key performance indicators. How many of you have seen this before? Show of hands. All right, so you've looked at the CPU Scheduler 5.1 white paper for vSphere. That is the last time that we updated the CPU Scheduler documentation. I would recommend that all of you look at that in some capacity because it will help you understand CPU and VMware a good bit. There's also a phenomenal book that touches on every topic we're going to go over in here that was recently released that I probably don't need to mention by name, but yeah, Frank Denneman's new book, okay? Absolutely way deeper than we'll ever have time to go over in here. So if you're really interested in this stuff and you want to go very, very deep on it, that's a great resource. That being said, let's talk about what's happening here. If we start at the new bubble, which is all the way on your left, when a new world spins up. Now, what exactly is a world? Okay? It's effectively like a service, and one is assigned to every single virtual CPU you give to your virtual machines. There's also some system worlds per virtual machine they're going to run, and if you're in ESXi 6.5, you have typically on a virtual machine with one vCPU, you'll see about 8 worlds. Where 7 of those are for kind of system management and maintenance, and you can go through them and look at them. There's a VMX world, there's display worlds, there's high resolution display worlds. But the ones we're genuinely concerned about as administrators of a vSphere environment who are performance consideration, or considering performance, we want to look at the CPU worlds, okay? In the vCPU world specifically, if I've got a virtual machine with 16 vCPUs, there's only one line dedicated to that in ESXtop. How do I know which of the 16 vCPUs is performing properly, which one is lagging, which one is not doing the work? What I can do is I can actually expand the view, okay? And it will show me all of the services that are used to keep that VM running and the ones that are associated with each individual vCPU. And if I have 16 vCPUs, I'll see vCPU 0 all the way through vCPU 15, okay? You'll find all of them there. And you can analyze the state of each vCPU. So when we consider state of a vCPU, which state do you think is desirable? Run. Yeah. So run is the desirable state. I want my virtual machine running as frequently as possible. But when it starts, it can't run. Instead, it goes to ready. Now, ready sounds like a positive thing. For those of you who don't know, ready is effectively a negative thing. And this is the first key performance indicator that we're going to talk about. Ready should not exceed 2 to 3 milliseconds. Okay? Generally, if it exceeds 2 to 3 milliseconds, or excuse me, sorry, I was confusing, 5 to 10 milliseconds, okay? And that's per vCPU. So 5 to 10 milliseconds per vCPU. Now, if you look at this through performance charts in the web client, anyone know the refresh rate on the web client real time? How many seconds? 20 seconds. Yeah, it reports this in milliseconds. So I just told you 5 to 10 milliseconds. Don't panic if you ever look at this in the web client and it says that it's 1,000 milliseconds. All right? It doesn't mean it's a full second. It's a full second out of a whole 20-second sample. Our samples, when we're looking at ESXtop, are done every 5 seconds, and you can modify the sample rate within ESXtop, which is a wonderful thing as well. Okay? So, ready, what does that mean? It means that we went to schedule the virtual machine into a run state, but we had to stop and pause in a ready state. Why? Because the ESXi host physical CPUs are not ready to process. It means the virtual machine is ready, but the hypervisor, CPU scheduler, will not permit it to go into a run state. So we start counting the amount of time that the virtual CPUs sit in that state. So if you have high ready times, that is an indicator of CPU constraint. Maybe your host simply doesn't have enough of CPU resources for the amount of virtual CPUs assigned to it. Or it could indicate that your virtual machine is just improperly configured. Okay? But it indicates that there's a problem of some type. So that's ready. Now from ready, you can go into a run state. And the only good thing about a ready state is that your next state's going to be run. Okay? So run is ideal. Now from run, we can be descheduled into a wait state, which we generally don't get too concerned with. as far as metrics within ESX top. And we'll look at these from ESX top in just a bit. But we tend to not get too concerned with weight because it doesn't actually concern us too much with the actual vCPUs themselves. Okay? When we look at co-stop, though, this is a major one. Right? Co-stop is absolutely critical. When we're talking about co-stop, co-stop is a situation where you've got virtual CPUs on the virtual machine. And this can only apply to SMP-enabled virtual machines, which means symmetric multiprocessing, which is a fancy, sound smart way of me saying you've got virtual machines with more than one vCPU. Okay? So virtual machines with more than one vCPU can have co-stop values greater than 0. Most of us have virtual machines that fit this criteria. If your co-stop value is greater than 3 in ESX top, then this indicates a problem. We'll talk about what actually happens with co-stop later. Okay? But effectively, virtual machines with more vCPUs than they need are going to experience co-stop issues. So when you ask someone what's the right number of virtual CPUs to give a virtual machine, very often they're going to respond and go, I think you should give a virtual machine as few as it needs. That's a common answer. Okay? Well, what if you gave it too many when you thought you were giving it as few as it needs? Co-stop is the metric that can help you understand whether or not you can reduce the number of vCPUs. Okay? We'll get into that more later. So these are the schedule, or the possible world states that our virtual machines can experience. There are actually other ones we'll see on ESX top in just a bit. So first, just for your usage here, we have all of the KPIs listed that I would recommend that you look at for virtual machines, CPU. So we have ready time, utilization, there's mentioning of load average. Now keep in mind, what you're seeing on the left is for the ESXi host itself. What we're seeing on the right is for the virtual machines. So you have your provider of resources on the left and your consumer of resources on the right. And we'll talk about how you look at that in ESX top. Okay? In ESX top, what you're going to find is that the provider is typically at the top and the virtual machine consumers are down at the bottom. All right? Because the VMs can only consume what the host can provide. So we talked about ready time, we talked about co-stop, we talked about, well, we haven't talked about MLMTD or swap weight, but these are things that can impact CPU, but they're memory related. If you're in memory constraint, it can negatively impact CPU performance. So when I get to memory, I'll address those as well. All right, this is interesting. So when we're going to identify CPU constraint, what do we want to look at? Like I said, above that line, the gray bar, where we have the column headers, that's all host-related metrics, okay? And the red box that we have at the top, where it says CPU load average, 2.08, 0.78, 0.29, that is the most recent 1 minute, 5 minute, and the last one's 10 or 15 minutes, I don't remember, but it's a load average interval that's host-wide, okay? If that number is greater than 1.00, you're using all of the physical cores on your host. It's greater than 2.00, you're well beyond what the host has as scheduling opportunities due to its hyperthreads. Okay? So, as we look at this, this host is in gross constraint right now. 5 minutes ago, it was doing pretty well. But right now, it is in gross constraint. And I was telling you earlier that when we hit Shift V, we can make it so that we don't see all of the system worlds. In this case, I've got a bunch of system worlds that are currently displayed: idle, system, console, helper, drivers, etc. I don't see any virtual machines on here at all. And that may happen to you when you go into ESX top. So Shift V is what you want to hit so that you see your virtual machine consumers down on the bottom. Okay? To be able to see the actual virtual machine's vCPUs, we strike the lowercase e key, and then we identify the virtual machine by its GUID. Okay, which is going to be listed in the column on the left-hand side. You can see GID is the second column header, and your virtual machines are usually going to have 6 to 8 character strings that are numerical that you'll use to identify the virtual machine's GID and expand all of its vCPUs and be able to see them and see whether or not they're running, whether or not they're in a co-stop state, whether or not they're in a ready state, so you can determine whether or not your virtual machines are suffering in terms of performance considerations. So how do I know when to right-size my virtual machine vCPUs? This is one of the most common things that I hear whenever I'm going through troubleshooting classes or optimize and scale classes. I'm an instructor as well. But this is one of the most common things. How do I know when to do this, right? Well, co-stop. We talked about co-stop earlier. So let's dig in a bit deeper and ask, what exactly is co-stop? It's when your VMs with multiple vCPUs are unable to process. So they're literally told they have to wait. Why does this occur? Because when you have 2 or more vCPUs on the virtual machine and one of the sibling vCPUs is progressing, meaning it continually gets scheduled to run, and the other one is not running. Maybe it's in an idle state because the virtual machine genuinely doesn't need it. Maybe it's just not getting scheduled because the host is in constraint. Whatever it is, if one is progressing and getting scheduled and the other one is not, eventually the CPU co-scheduler mechanism inside of the VM kernel is going to recognize what's called skew. It's got a threshold for skew between these 2 vCPUs. When it recognizes this, the one that keeps progressing is effectively going to have to wait for this one to get processing time, okay? So that they can catch up to one another and they're not violating the skew threshold. So when you see co-stop is in excess of a value of 3, and that's typically the KPI that makes us want to react, it's probably one of those situations where you could benefit from reducing the number of vCPUs on your virtual machine. Now this is something that you can't just take this and do it every time and assume that it works. You have to test it and make sure that it's actually functioning the way you intend. But I've been in customer environments where for whatever reason, they built virtual machine templates with 4 vCPU sockets and 4 vCPU cores on every single machine in the environment. That was the smallest machine that existed. They had co-stop issues all over the place, okay? So how do I resolve CPU co-stop issues? Right-size your virtual machines, okay? Right-size the vCPUs, make sure they're allocated the proper number of vCPUs, and you can analyze their performance through ESXtop and make sure that you're doing the right things, okay? And you can look at it, once again, on a per vCPU basis on each of your virtual machines. You can also consider what's called a wide and flat virtual CPU allocation. If you've never heard this term, as you're going through and reading any of the performance books that are out there, you're probably going to run into this, okay? Maybe there's a few blog posts on this as well. But this is the idea of giving X number of virtual sockets with a single virtual core. And what this does for you is if you have NUMA enabled, physical NUMA enabled on your ESXi host, which is non-uniform memory access, which I don't have time at all to get into that. But if you guys want to take a break after this and go whiteboard for 30 minutes, we'll talk NUMA. Let Steve and I know. But yeah, if you're considering NUMA, then your vCPU cores and your vCPU socket allocations are absolutely critical, okay? So if you've never considered this and you're having CPU performance issues and you don't know what your NUMA topologies are on your ESXi hosts, that's something to consider, all right? I decided to omit that because we simply don't have time to go through all 4 of the resources and cover that. So when we look at memory key performance indicators, we're going to shift from CPU now into memory. And when I cover that, we'll first look at the fact that our ESXi host has a very quick indicator to tell us whether or not the host is happy in terms of its memory consumption. So it's going to consider the memory it has available and what's being consumed by the virtual machines and the system processes. Everything that's consumption related is below the black bar there. And the stuff that's above the bar is ESXi host physical RAM management. All right? So, question, does anyone know what ESX stands for? Just yell it out if you do. Elastic Sky X, okay? So, it may come as no surprise then that our host's ideal state from memory consumption is, I'll leave that to you. So it's a high state. If your host happens to not be in a high state, it means that it doesn't have enough of memory. The alternative states that your host could experience are clear, soft, low, and hard. Okay, we'll talk about what each one of those means. And we'll talk about the threshold of memory consumption on your host when the ESXi host will shift into one of those undesirable states. If your host is in one of those states, ideally, you'd like to vMotion your virtual machines off of that host. Add more memory to the host. You can't hot add physical RAM on an ESXi host, but hey, if we could, that'd be great. Typically, this is something where DRS is going to reactively resolve the situation by migrating virtual machines for you. Or if you have the preemptive DRS function in the newer versions, then you would have that working for you as well to prevent things like this from happening. But it's virtual machine consumption because we've allocated RAM to our virtual machines that will dictate when the host is going to shift into these alternative states. So the other thing that we look at here is the fact that your ESXi host has a pmem and a vmkmem value that's up there. The pmem is all of the physical RAM installed in the ESXi host. It's all of it, okay? Now, vmkmem is the VM kernel managed memory on the ESXi host. And this is a kind of weird thing. When you're looking at this, you see how it says pmem/MB4095 total, okay? Typically, the way that I read things left to right, when there's a colon, I assume that the number I'm looking at is referring to the string of text prior to it. That's not how we read this. The way you actually read this is 4095 total, and then you look at the next metric. Of that 4095 total physical RAM, 804 of that is VM kernel allocated. 1228 of it is in use by other, which is typically your virtual machines, and then 2062 of it is currently free for additional virtual machine consumption. Okay? So that's how we read this. Not the most intuitive thing when you're looking at it like this. So there we have the free value, and that's the free RAM, so I know that I can power on more virtual machines as long as they consume less than that. If they consume more than that, I can still power them on as long as I have enough disk space to create my swap file, but they'll get powered on, and if they use the swap file, we're going to have terrible performance probably. Okay? So when we look at the memory state thresholds that we were talking about, we have a value called min-free, M-I-N-F-R-E-E, that's determined on every ESXi host. And min-free is typically going to be a little greater than 1% of your total host RAM. Okay? There's a way you can go through and calculate exactly what it's going to be, but you don't need to because the ESXi host will tell you if you go on ESX top. So what is our min-free? Let's see, do we have that here? Yeah. If you look at VMK mem, the third line down inside the red box, and then 4077 is managed, and then you have 244 min-free. Okay? So on this particular ESXi host, which only has 4 gigs of RAM, the min-free value is 244. If you have an ESXi host with 512 gigs of RAM, which is probably more realistic for many of us, then your host is probably going to set that threshold at about 6.5 to 7 gigs. Okay? It'll be somewhere in that range. Now, what happens when we see these state shifts on the ESXi host, going from high to clear to soft to hard to low, what actually happens there is that the min-free value is being violated by consumption. Okay? That threshold has been breached. Now the host shifts into a clear state. If we stick with our example of a host with 512 gigs of RAM, the host is going to shift from the high state into a clear state at roughly 100% of min-free. Okay? But when we're 300% of min-free, we're going to execute a call to break large pages. What does that mean? What's the normal size of memory in an ESXi host RAM page? Anyone know? What the size of a large page is? 2 meg. Okay? Now, if your virtual machine guest OSs are requesting large pages, the host will give large pages. If it requests small pages, we'll give small pages. Small pages are 4K in size. All right? So when the ESXi host is threatened and it feels like it doesn't have enough memory left to give or keep everything running well, it does something called breaking large pages. So we burn CPU cycles. And this is where we're going to get into a discussion of how you never want to run out of memory on an ESXi host. Because if you run out of RAM, you're going to negatively impact CPU, network, and disk as well. All right? So this is the first example of that. When we're low on RAM and we break large pages, we go from 2 meg pages and we break them up into 4K page sizes. The reason why is because then we do something called transparent page sharing. We have an active call for that when we shift into the clear state. Transparent page sharing is nothing more than memory deduplication. We don't deduplicate 2 meg pages in the RAM space. We only do it with 4K pages. Hence, the break large pages occurs at 300% of min-free. Hopefully the memory deduplication can stave off some of the more undesirable effects as we shift from clear to soft. When you get into soft, at 64% of the min-free value, soft is going to start ballooning. Ballooning is when we actually send a false notification to the guest OS informing it that it's out of RAM. When a guest OS is out of RAM, what's it going to do? Page or swap. Exactly. So when the guest OS starts doing that, now we're taxing the network on the storage network to get that memory into the disk, and we're taxing the disk I/O as well because we ran out of RAM. Don't run out of RAM. Okay? So as we continue, we get to hard, where we then add in compression. Compression takes the 4K pages that we've already broken from 2 meg down to 4K, and it compresses them into 2K zipped files in the RAM. While they're zipped, they're inaccessible. It's faster for us to compress and decompress in the RAM space where RAM operates at nanoseconds than it is for us to go to the disk and have to retrieve the memory that's running at milliseconds or microseconds. Okay? So this also, compression, further increases CPU utilization as a result of us not having memory. Okay? Now, if compression is faster than going to disk. Why is it that ballooning occurs before compression? If you're a guest operating system and you're told that you need to start pushing memory to disk in your swapper page file, which pages go first, idle, active, or free? Idle. Yeah, what's the net effect of having an idle page go to disk? The network I/O and the storage I/O to get it there. Other than that, we're good from a memory perspective. So that's why ballooning takes place first, okay? Note that you have to have VM tools installed in your virtual machines in order to actually leverage ballooning, okay? If you don't have VM tools, you don't have any ballooning. You immediately then go to swap if you don't have VM tools and you can't run ballooning. Eventually, when we get to swap, this is vSwap, okay? All your virtual machines have a vSwap file. Unless they have a fully locked reservation, their vSwap file will be 0 if you do have fully locked memory reservations, but that's rare, okay? If you don't have fully locked memory reservations, you will have a vSwap file that is typically the exact same sum of the amount of RAM allocated to your virtual machine. If you give a virtual machine 64 gigs of RAM, every time you power it on, it creates a file that's 64 gigs in size to be able to swap the memory to disk, okay? So keep that in mind when you're building data stores. So when swap occurs, what's going to happen is the hypervisor just starts grabbing pages of RAM and throwing them on the disk. The hypervisor has no cognizance as to whether or not pages are active, idle, or free. And guess what? It doesn't care. At this point, it's got so little RAM, it's just trying to keep itself alive. So it starts just shoving VM pages to disk. This will have a negative impact on performance, all right? Guaranteed. Because when an active page goes to disk, you just went from nanoseconds to milliseconds, and that is brutal. So let's actually look at the screens a little bit more. And when we look at our ESX top with our host memory shortage KPI here, what we've got is first the MEMCTL value. The balloon driver that gets installed in your virtual machines with VM tools is called MEMCTL, hence that value. Now remember, I told you everything above the line is host-wide, right? So if everything above that line is host-wide, this is the host-wide swap that is taking place. Or excuse me, ballooning that is taking place, okay? Every virtual machine can balloon up to 65% of its memory allocation by default. The remaining 35% can be stolen by vSwap if the host needs to. Your VMs aren't going to run if that happens. I don't care if you have SSDs or not. So this field, this column, will tell us if the balloon driver is installed on our virtual machine and functional. You might have it installed, but it doesn't get recognized. Then you don't have it there for you, okay? So if there's a Y, the Y indicates yes, it's installed and functional. The N indicates no, it is not, all right? We also have the MCTL SZ, TGT, and MCTL max that lets us know the maximum that that virtual machine can balloon, and that's the far right column. And we can see that this virtual machine is currently ballooning exactly that much. So it is in a worst case scenario state, okay? This virtual machine is probably not going to be performing too well, and this could also impact our CPU. What happens if we're trying to process against a page of memory that's sitting on disk right now? The CPU has to wait for it to be retrieved from disk, loaded back in RAM, execute on it, and then it probably gets pushed back to disk, okay? So that's extremely painful. And that gets into the %MLMTD value that we'll look at in just a bit, and also the % swap wait value. Now, the SWPWT that we mentioned earlier in CPU as one of the KPIs on that slide that I said we get back to. When your virtual machine can't process because it's waiting on RAM that's on disk, the swap wait value will increase. And that's a CPU metric that you'll see on the CPU screen, okay? So when we're looking here, we've got the amount of memory configured per virtual machine. That's MEMSZ is the column header there. 65% of that value will be the MCTL max value. Like I said, we can balloon 65% of a virtual machine's allocation. Physical memory held for other virtual machines is over there. Now, when we say physical memory held for other virtual machines, what we mean is the host physically was able to reclaim all those pages of RAM by having that VM push them to disk. So now we can share it. That's all of our physical memory target to reclaim. Now, this is going to help you understand what the current state of this virtual machine is. When this value is high and the size value is lower, it means that our virtual machine's target to actually balloon and push to disk is that value. You really don't want that value to ever increase. But if you do start ballooning, that value is going to increase first, and then the MCTL SZ value will slowly start to increase until it converges with the target. The target is what we want to do. The MCTL SZ is what we're capable of doing right now. Okay, it's what we just did already with the memory. Now, you may see, and this is a big point, you may see at the top above that black bar that you've got ballooning, compression, and swap on the ESXi host. Okay? When the host has to engage in these activities, it does not give the RAM back to the virtual machines until they request those pages. Your host could be in a high state and exhibit tons of ballooning and swap and compression. And the virtual machines, if they don't ask for those pages back, we're never going to give them back. So your host could be just fine, your virtual machines could be just fine, and they could have large sums of RAM sitting on disk because they've never been requested after they were pushed out. Okay? So just because you see ballooning, swap, or compression doesn't necessarily mean that you have it actively occurring, and it's something you need to be worried about. All right? Very often, if you've got an ESXi host that's got an uptime of a year, 2 years, 3 years, and you go look at that ESXi host, it probably should have been patched, but you go look at that ESXi host, I'll point that out. Don't be proud of those uptimes. If it's your home lab, good job. But if you go look at those ESXi hosts, you'll probably see those values are up there. And it just means that at some point in time, that VM had to do this, and then we're good now. Okay? Active memory per VM. So let's talk about compression. Compression is up there, and that is host-wide compression. The only way that you see ballooning, compression, or vSwap, which is the one above that we'll look at in just a second, the only way you're going to see these values is if the virtual machines have actually done it at some point in time. Doesn't mean that they're actively having issues, but at some point the host had to reclaim memory. Okay? Because the only way that the host gets memory back is by these processes. When we give a virtual machine a memory page, we don't get it back until the host goes into constraint. Okay? So there we have our cache size, which is the compression cache for the virtual machine, the cache used for the virtual machine, and then your zips and unzips are basically your I/O. It's, you know, how many zip and unzip operations do we have to do for the pages that we're trying to access. Okay? If the OS keeps requesting those and the virtual machine's requesting them, we're going to zip and unzip as much as we have to. Swapping is the last resort, as we saw earlier, and swap is defined by this value up here. Okay? Much like ballooning, it has a target value as well as a current value. The target value is RCL MTGT up there, and the current is, in this case, 198. Now this is an interesting situation. The target is lower than what the actual current is. Okay? And my host is in a high state. This is a situation where the ballooning had occurred, or the swap had occurred as well, but really the virtual machine, the problem is probably subsided on the host. Host isn't having a problem, virtual machine should be fine. The VM just hasn't requested those pages again, so we left them out there. Why take on the penalty of moving those pages out of the storage back into the memory if they haven't been requested? Okay? Over here we have the actual access to the pages that are in RAM, the pages that are in disk that are RAM pages. So if I've got a lot of swap and it's not being used at all, I don't really care. But if it is being used, that's a big problem. Okay? That means we're actually trying to use pages that are sitting on disk operating at milliseconds or microseconds for a resource that should be reacting in nanoseconds. Here we have our swap current value, our swap target value, our reads and writes, and these you can look at on a per virtual machine basis. Okay? All of these are virtual machines, and you can see their GIDs on the left. You can't expand the view for virtual machine memory. Just for things like CPU and also for disk and for network, you can expand them. And you'll see that when we look at some of Steve's stuff. So here we look at the CPU screen. Why are we back to the CPU screen here? Well, because I want to call your attention to this. This tells you that your CPU is unable to compute because we're waiting on RAM to come back from disk. Okay? If this value is greater than 5, you've probably got a pretty serious memory issue. Okay? Typically, if this is greater than 0, you can hit the M key, you'll strike over to memory, and you'll see real quick that you've got memory contention issues probably. Okay? And that's it for me. So thank you so much. You good on time?
What?
You good on time?
Oh, yeah.
Yeah. They were clapping for you, man.
They were.
You got this.
Yeah, right. All right, thank you. So networking key performance indicator. So Brett did the CPU and memory. He did the hard ones, so I get the easy ones. But in reality, all 4 of the resources are very important to your virtual machine. So the first one, well, the third one, I should say, networking. What you have is we've got a couple of different places that we need to be aware of. So from the virtual machine to the virtual switch, we've got a measure there for those virtual NICs. And as those VMs communicate to the virtual switch and go down to the physical NICs, there's really kind of two places where we can actually see the measurement of what that performance is. And here they start showing, this is the measuring the network bandwidth per virtual NIC. So we have a lot of measuring happening. We can also measure the packet count, and that's, important. How are we doing on packets? How many packets are coming? But when you think about it, it's drop packets, and for the longest time, that was kind of one of the first things you look at is, are we dropping packets? And that number should be 0, and maybe every so often you have a drop packet, that happens. Well, and then we can measure down at the physical NIC level, again, measuring the packet count and the average packet size per physical NIC. And so we've got ways to, within ESX top, and then finally, we're measuring the drop packets per physical NIC. Whoa, that didn't come out too well.
I don't know.
Yeah. What happened on this slide?
I don't know. Well, we can't troubleshoot it here, so let's just go ahead and move.
Yep. So,
go ahead and go back.
Right. All right, thank you. I appreciate it.
Is there another one you need us to hit? Perfect.
So what you can barely see here for some reason, I don't know why.
Do you have another one? Just see if the next one works. Just bounce to the next one and see if it's the proper size. There you go.
Oh.
Just use this.
Now that's really huge.
Yeah, but just use that.
Let me just explain something there. What you're seeing though is you're seeing two VMs, and the top one there is got 10 worlds in it. And then I broke down the second VM by hitting that expand that Brett was talking about within ESX top. And what you have then is you can kind of see it. There's an option there, and it's called NetWorld. It's kind of hard to see there. But the NetWorld part, what it's showing is this. It's showing between the virtual switch and the physical NIC what your performance is. And the other thing that you would see there is how busy the CPU is. And that CPU is about 85%, which one thing that tells you is that performance-wise, the CPU greatly affects the performance of your network. Also, the field sys, the percent sys, what that shows is, well, what is my performance for the TX threads between the virtual machine and the virtual switch? But we'll move on from that. And from that can also tell you if you have any type of latency. Now, key performance indicators in ESX top. So here we've got a couple of VMs, workload 04, workload 05. And what's nice about this tool, although there's not a lot of activity, is I can look to see, well, what physical NIC and what switch is that virtual machine running on? Is it the correct one? Sometimes you look at it and it's like, well, why is that VM running on that virtual switch? That would be a problem. And then you can see to the right again is lots and lots of fields. And if you go in, you can obviously add, I shouldn't say obviously, but you can add and remove fields. Look at the help page. There's some ESX top help articles out there that can explain how do I see the fields that I want to see, especially if you don't have a really large monitor. And then, a key then would, of course, be the drop packets as well. And I can also see, here I'm seeing the network bandwidth transmitted per virtual NIC and the packets transmitted per virtual NIC, and then, of course, your average size. And those would be things that you would look at to say, is this what I expect to see? Now here we've got some more key performance indicators, and now I'm looking at it from the virtual switch view. Now notice within ESX top, I enter in the letter N. So if I'm looking at the CPU page and I want to switch views, I just hit the letter N for network. And it'll switch, and then I can see my performance. Am I dropping packets? Maybe you're looking at this and you're saying, well, why am I not sending out any packets? Or maybe I'm sending it out on the wrong switch. So these could be very useful. And again, most of these fields here in the instance of time, you can kind of figure out, yeah, you know, these are the packets received per virtual NIC. And then, of course, the drop packets. And the drop packets should be 0. And you can, and that would, of course, every so often there might be one, but it should be 0. Now, when I go and type in my N to display the network screen, again, here I can see my virtual machines. I can see my virtual machine NICs. And so I can say, yeah, VMNIC 1 is running on virtual switch 1. And I can see, you know, again, you know, what is my, am I dropping any packets? How many packets are transmitted per physical NIC, as well as your network bandwidth. And then in this slide here, we're looking at it from, you know, again, looking at it from the packets received per physical NIC. So before we were looking at it from the virtual NIC view, now we're looking at it from the physical NIC view. And this page here is simply saying, you know, this is one of the key features we want to look at is, are we dropping packets? And those you know, you could drop packets in a number of ways. I mean, one, it's just, you know, bad driver, things like that. So that can cause problems. So let's take a look at storage. Now, on the storage side, you've got your IOPS, you've got your throughput, and you have capacity and latency. Now, one of the problems with looking at your IOPS and throughput, and that is, you know, do you know what those values normally are? And that's one of the problems on the storage side. And that's why there's a product like VROPS. Because with VROPS, I can go and look to see what is that threshold. What is my normal rate of IOPS and throughput? Because if you're looking at ESX top and you don't know what that IOPS and that throughput is, on a normal basis, when you look at those numbers, you're like, I don't know, it looks good to me. Maybe it's high, maybe it's low, I don't know. So that can be rather helpful, having a product like VROPS. Now, what are IOPS? And, you know, and that's a good question. So you know, and again, they're saying that IOPS are, you know, disk inputs, outputs, or reads, writes per second. So how much transactions are happening on that system? What is a SCSI can? When you think about it, for all these years, what are we doing? We're passing around SCSI packets. I always like to think of it as you're going back to the 1970s. You know, you're still passing SCSI packets around the network. And so what is a SCSI reservation? Now, the nice thing about that is with VAAI, you no longer really have that type of issue. Because with SCSI reservations, you know, that was kind of old school. With VAAI that was started in vSphere 5.0, as long as your storage array can handle VAAI and has written into its operating system, then it's going to go ahead and, you know, handle that for you. So you're having the storage array handle those commands, and you look to see in ESX top if you have any atomic tests and set. So one of the nice things is if you type in the letter F within ESX top, you can go see what those fields are. And you can go and add in, am I doing VAAI? You know, that's just one way to see that. And then, of course, the big thing is latency. If you think about it, latency itself is how long does it take for me to go and grab that data. Here you can see within ESX top, now I've got 3 different views. I can look at it from the disk point of view, I can look at it from the virtual machine point of view, and I can look at it from the adapter point of view. So I have the V, the U, and the D. So let's take a look. And before we get there, a couple of key things to monitor. Now what's interesting about the top one, the D average. When somebody says, hey, I'm having a problem with my storage, one of my eyeball, immediately, you know, I go into ESX top and I look at that D average and what is that latency? If it's higher than, you know, here 15 to 20 milliseconds, that's too high. But now keep in mind with a lot of your newer storage, like Tintry and Pure and some of the others, you might want to look to see, well, what are what are the latency expectations there? Because they are starting to kind of change some of the game, how some of that latency comes about, and so it might be lower than that. So it is kind of based upon your storage. You've got your kernel average. Now, this is when I say, hey, I need some storage, how long does it take to go to the VM kernel and acknowledge that? So that should be less than 2 to 3 milliseconds. And of course, we want all the IOPS. We want really high IOPS and really low latency. And then, of course, your SCSI command abort saying, for one reason or another, and most likely, maybe you've got too many outstanding SCSI commands, which is something you can see in ESX top, that might cause an abort with the timeout. So within ESX top, if I type the letter V, notice I can see from the virtual machine level, I can see my IOPS, I can see my throughput, and my latency. And again, the IOPS should be really high, and your throughput should be looking pretty good. But again, if you don't know what that normal threshold rate is, you can look at that and say, well, I think it looks good. I don't know. Maybe it's good. So then it kind of comes down to latency, and you want and with that we want to obviously as low a number as possible. And I can then look with you. I can look at, as an example, here. My guess is might be a iSCSI device. So I'm looking at it from kind of that LUN point of view. And you can see the number of commands. And again, IOPS throughput. Notice the D average there, 6.81. It's not bad, on most storage. But maybe for this type of storage, maybe this is too high. So again, that's one of the numbers that you want to look at is what is my normal expected latency as our storage is really starting to change now. Then you have the K average. That should be extremely low. And then the D average plus the K average equals the guest average. Also keep in mind that in some cases, I know it kind of equals 6.81, 0.01 equals 6.82. Don't be alarmed because they truncate some of those numbers. It might be like 0.83. It might be off by 0.01. That's just how the math is done. Because again, ESX top runs every 5 seconds. And then you've got your Q average on the end. And then finally, from my D average. So I've got 3 different views I can see right there.
Yeah, you got to go back.
What?
We got pictures.
What happened?
They need pictures.
Oh.
All right.
Good?
We good? Oh, you let us know when you're good.
We got 12 minutes.
Perfect. Next.
So, and here's just a nice picture showing, what's my V showing? Yeah, again, the virtual machines. D showing from my storage array, and then U showing from that LUN view. Whoops, sorry. Let me go back. There you go. All right, good?
Go ahead and continue. If you guys need pictures, we'll get them at the end because we're running short on time.
Okay, yeah.
So, yeah.
So here we have the HBA view, and what we can see down here is, in some cases, I'm looking at that VM HBA33. Well, what is that? How can I match that up with my storage? And notice from the vSphere client, I can come down here and see this iSCSI software adapter. I see the VM HBA33, and there's my IQN. And that's how I can go about matching up between the two. And then for the disk-backed storage, here again, we've got the GUI-based storage, and then I can equate that to ESX top, because sometimes that can be a problem, especially if you have a lot of storage. All right. ESX top VM view. Now in this case, it's kind of nice. I've got a virtual machine called util-01A, and I went and expanded, so notice I typed in the group ID for that particular virtual machine, and I broke it down by both VMDKs. And that allows me to see, well, what is the performance on each VMDK? maybe one of them's a problem and maybe the other one's 0. That can cause a problem as well. And then here you have your latency. So you have the guest average, again, which is, that K average plus the D average. So you're looking at what's my disk average. Again, the time for the iSCSI command to exit the VM kernel, hit that physical storage device, and return. Also, you've got your time spent in the VM kernel. And then we've got our queue on our ESXi storage stack. So what does it mean when metrics on that device, LUN, VM are low, high? That's also kind of a thing to think about. So if I have a high D average and a low K average, it's going to be an overworked array. And let me just go ahead and do this. There you go. So, and that makes some sense. We want, it's going to be the array because it's that high D average. While if I have a high K average and a low D average, that wouldn't be a sign of the host because the K average is the kernel. So I'm trying to go to that ESXi host and there's something else there that's slowing it down. Now, if they're both high, the problem could be both the host and the array or the CN queuing. So you get into, there's lots of queues that happen within within the environment as well, within the kernel, within the storage array, to that effect. And that takes us to kind of the end. Now, a couple of things. If you're interested in, there's additional educational resources. If you go up to the Education and Certification Lounge in the VM Village, maybe you want some of this great flair like this guy here has. So if you have like your VCP and your VMware expert.
One piece of flair per customer. Pending validated certification. They're going to check and make sure you've got certs.
Yeah.
But yeah, if you have it, they'll be happy to give you a badge that represents that you have your VMware certification. So I
just have the minimum amount of flair.
That's at the EDU booth inside of VM Village. It's in the back of VM Village, and I'm going to be there for 4 hours tomorrow, and I think it's 1:30 to 2:30 or so, 1:30 to 4:30. Excuse me. Are you going to be there?
No.
Okay, so I'm there tomorrow. Lucky him, huh? I didn't have to go today. But if you have any questions that we don't have time for today, if anyone first off has any questions, please feel free to ask. Anyone? Yeah. The slides? They're going to be available if you search for the session number whenever they post. They should have the whole thing recorded.
Oh, yeah.
I don't know. What is SER1534BUR? Is that it?
I think so.
Go back to the front. Yeah, thank you. It's down there. So in addition, come see me when you're done and I'll give you some additional resources that are actually better than the slides to go deeper on this stuff. Right. I'm sorry, question? Is all this going to be available after the next VMworld? Yeah. Usually it's within a few weeks of VMworld, they've got everything up.
Yeah.
Some of the stuff is live. We're actually doing the same session in the education booth. I'm doing it tomorrow, I think. Yeah, I'm doing this tomorrow, and we've got another breakout for this on Thursday.
Resources like book resources and stuff to go deeper into the troubleshooting stuff like that.
Yeah, just shoot me. You've got my Twitter handle, so yeah, it's just at Brett_Garino, and I'll be happy to work with you on that or whatever you need.
Oh, yeah. It's host.
Very good on performance.
Frank Denneman's book. However, I will say, I don't remember what he called it. Let me look it up real quick.
Host Deep Dive, isn't it?
No, it's not Host Deep Dive. It's something Deep Dive. Host-based deep dive, is that it?
Host resource deep dive.
Yeah, host resources deep dive, is that it?
Yeah.
Frank Denneman, though, you can't miss it. It's in the bookstore.
It's about $25, I think. It's
there it is. Thank you. Look at this.
There you go.
Oh.
Yeah, there you go.
So there you go. Now, this is extremely, extremely deep, okay? This is, I'm not even kidding. I've been doing this for almost 15 years now. They had 2 previous iterations of this book that were nice, easy weekend reads. That's not what this is by any means. Okay? It's intense.